Hello, everyone, and welcome to the Alloy Community Call in April. This is our first technical Alloy call since we have just launched it and changed essentially the name from Agent to Alloy. So I just wanted to give maybe a little 5-minute spiel here at the beginning about what Alloy is. Positioning Alloy has an open telemetry collector that includes all the Prometheus, Loki, Tempo, Prometheus kind of functionality that existed before in the agent. At its heart, it is essentially a flow mode with the static mode stripped out and moved to a new repo. Now, part of me wants to get into a little bit of reasons why we did this. And some of it is we wanted to have a kind of strong step forward and make sure we kind of have a clean separation from static mode. Static mode is the YAML-based, very Prometheus-inspired mode for the agent. And the Alloy uses Alloy files that were formerly known as River and gets rid of all the static and is fully committed to running Alloy files and open telemetry and kind of building programmable pipelines. Now, part of the reason we had this 1.0 and the rebranding is to have what we're calling stability promise. So beforehand in the pre-V1 days, we would have a breaking changes and we would try to limit those, but they happened. Now we are promising that we will not have any breaking changes to anything that is labeled as stable. And that is not a security issue, or maybe if a setting or something was specifically a bug or added an error and wasn't used, we may remove it. So there's a few carve-out exceptions, but for the most part, we're going to follow semantic conventions there. Speaking of stability levels, one of the actual changes between agent flow mode and Alloy is you have to opt in for stability levels. So this could be where beforehand, you could use experimental or beta components and everything was fine. Now you have to add a command line flag to opt in. And the reason we do that is because those components do not fall under our stability promise. We can change those. Beta has less chance of changing. Experimental have a high chance of changing, because we're playing with them and trying to figure out the best way to do them. So and then everything else is pretty much the same. It is a different image. It's a different executable. There's slightly different naming there. We did change some of the pathing on Windows. It's now under Grafana Labs folder. The names of the executables follow a slightly different paradigm. But functionally, it's the same as agent flow mode. Speaking of agent flow mode and agent static, those we will support for 18 months with maintenance. This is probably security fix and bug fixes. There's not going to be much in the way of new enhancements. That should come as a surprise to no one, especially with static mode. We haven't really made many changes to that in the past 6 months to a year. And now we're kind of extending that to the old flow mode, with most of our development going to be in Alloy. The conversion from the two, ideally, should be changing your executable or image, maybe adding that stability flag, and you can pass in the same configuration. And I think we've removed one component, the vSphere component. So if you're not using that, your configuration should follow through, no problem. The only other thing is removed Modules Classic, and are now using the Modules v2, which allows you to create custom components instead of more of a input-output pipeline. It's more function-based. I don't know, that might be the best way to describe it. But it allows you to create custom components, and we have some documentation on that. And it will probably be a point for a future community call here. Looking at my list, that's probably the most things. We have a We have FAQ out. We have several blog posts. We have several videos that I did for kind of giving an intro to Alloy. But if you're familiar with Flow, you're 90% there. And then we had a blurb in the GrafanaCon keynote, and then myself and Pascalis gave a overview on Alloy, and that's currently being processed, and ideally will be uploaded to YouTube in a week, maybe 2. The cliff notes of that is basically we cover the syntax, how we built the ecosystem, and what we consider some of the magic sauce over top the OpenTelemetry collector, which be our Alloy runtime and our Alloy specific components like remote vault, clustering, modules, kind of those advanced features, which as the weeks go on, and community calls go on, we'll dig into those a little bit deeper in each individual one. All right, that's really all I had. Like I said, I expect to be pretty short. I'll open the floor for any questions. If you have any questions, you can feel free to type them in the chat or bring them up, and I will give a minute or 2 for anyone to add those. We're waiting. We're going to keep the same release cadence, so every 6 weeks we will release a new version. We will keep that roughly in line with OpenTelemetry. They have a slightly different release cadence, so we may be a release behind on occasion, but we're trying to limit those gaps where it's months between updates. So that's something we're actively working towards.
Hey, Matt, this is Harish. One question on the clustering size.
Sure.
So what do you guys recommend, like how big a cluster size can be? Because we have in a production cluster where we'll be getting 500K Prometheus metrics per second. This is more, my question is more towards like the Prometheus collection based on clustering mode. I'm not worried about the hotel thing. I'm just focused on the Prometheus metric collection. So what do you recommend over there? Like, can you do you recommend like running multiple clusters or like one cluster with a lot of peers in it?
So we run a lot of clusters internally across many different regions. So in each one of those, we generally have 4. We separate telemetry types into their own kind of namespaces. But if we're speaking particularly of Prometheus metrics, which are the only ones that really support clustering really well, that we have the most use case for with clustering. We have an HPA to scale it up. I would say we run anywhere from 12, to 30, 40 instances of Alloy in a cluster, and we have tested it, I think, at least to 150, maybe 200. The overhead's relatively small on keeping the cluster kind of in sync. The only thing is whenever you scale up or scale down or add nodes or remove nodes, it's easier to do that one at a time. If you do a whole lot at once, maybe there can be some more movement of the metrics than we would like. And occasionally you can see some stillness markers move if they move from a metric moves from one to the other, or a target moves from one to the other. But we generally roll out one at a time, and that seems to handle it pretty well. I don't know. Did that answer your question?
So what are you saying is like the gradual increase or decrease wouldn't add any latencies. Rather, it's the sudden spike of peers with joins would add some disturbances. Is that right?
Yeah, I would much more go toward gradual increase and decrease than large increases and decreases. Go ahead.
Yeah, and what size do you recommend, like the max? Or should we test it out and see like how it behaves?
Yeah, I mean that's always tested out as much of it. Like I said, we run. I don't think I can give exact numbers, but we run relatively large scale with 30 nodes. Now those nodes are relatively well provisioned. Lots of CPU, gigabytes of memory. In our largest ones, like many gigs of memory. So it is better to run fewer large nodes than it is many small nodes, I would say.
Okay.
You probably have less churn that way. But it is kind of dependent upon your environment. Now, I know we have in the pipeline to release some documentation on t-shirt size air clusters. So we have like, I think it's 4 or 5 small, medium, large, extra large. So 4 rough categories we do based upon the number of metrics in the cluster. So we're looking at how we can make that into a blog post or article that kind of will give more guidance. That's like, hey, if you're roughly handling this number of things, this is what we recommend. Or if you're handling this number of things, this is what we recommend. Now, the only thing with that is only for metrics. If you're trying to do like an Omni cluster where you're handling like logs or profiles especially can have a high CPU cost, and that changes the equation. But we will release something that's some guidance on rough cluster sizes per kind of your environment and the expected metric load and the expected number of targets.
Gotcha.
See if I can pull up, maybe share a ballpark figure of how many metrics did you say you were running or looking to run?
Yeah, so our largest cluster has 700 nodes, and probably we are looking at anywhere between 300 to 400K metrics.
Oh, K metrics? Okay. Yeah,
Yeah.
you can handle that, no problem. I would 3 or 4 or 5 nodes, see how that handles. I think depending on how much you provision them, I think you'd be fine there. I don't think that would be a problem at all.
Gotcha. Okay.
Let me see here. I was trying to get actual.
Yeah.
Seeing if I can get a ballpark number here.
Mm-hmm. Yeah, just to compare with the Prometheus operator, right? Right now, even 1 TB of memory is not enough for handling that many metrics.
Yeah. Yeah, so we're handling like hundreds of millions of metrics in our clusters in a single cluster with the clustering enabled. Now, granted, you need more memory and CPU for that, but from a scale perspective, it's no problem handling hundreds of million.
Gotcha.
But honestly, with a few 100,000, the guidance is generally 4 to 8 kilobytes per sample that you need. So you can probably extrapolate how many nodes you need based on that, based on how big you make the nodes. And that's clustering doesn't really change that math any. And then CPU, it kind of depends on what regex and relabeling you're doing. If you're doing very little, you can get away with a lot with very few CPUs. If you find you're got extremely complex relabel rules, then you can up that CPU. The other thing you can do is on the relabeling components, there is a cache there. You can increase that cache, and that'll reduce the CPU if you've got a lot of metrics. So I would, if you're running a few 100,000, I would honestly make that cache depending like 5 times whatever your single largest scrape is. But that's a number you can play with to kind of trade off between CPU and memory.
Gotcha. Yeah, it was always the memory. CPU was fine.
Yeah, CPU is generally only a problem if you're running profiles in our experience, or really like thousands of regex rules. Memory is almost always the thing that's in tight demand. And there's some changes that we need to import from Prometheus that will get some savings to memory. They're like single digit percentage changes. But gaining extra memory here and there is always good.
Yes, of course. Yeah.
Cool. Do you have any other questions?
Yeah, I think the other questions you answered that on our Ally Slack channel, so I'm good. Thank you.
Okay, awesome. All right, then. We will cut it here. I appreciate everybody showing up, and this will probably go out on YouTube in a few days. And we'll see everybody next month. Thank y'all for coming.
Thank you, Matt. Thank you, Tim. Bye.